We are connecting to a lag compensation enabled backend server that's deployed across the country from me in the cloud. And I've got 2 peers running locally on my machine. And you can see that it is syncing in real time. So we don't really have that lag. So this is lag compensation enabled. I can jump. You can see it's pretty smooth. The only issue I'm seeing right now, which I'm still going to have to work through, is there's a little bit of jitters in the turns and the rotations of the player. But other than that, I've got the animation syncing, movement and jump, and even we can even run around a little faster if you hold down shift. So how did we get to this point? So from the last stream, we had basically wrapped up our movement state machine. And in the next stream, which was like a week or so ago, I looked at how do you enable Netfox in your game. This video is going to be in 2 parts. The first part is just the basic review of where we left off with setting up Netfox from the last stream. And it's going to get to a point, and then the second half is going to be me just reviewing what's going on in the code and what I had to end up doing to get it to work, because it ended up being a couple days effort. And I even had to go and talk to the guys in the Fox Sakes, the Netfox guys Discord, to try to get some clarification on some stuff. But I think we've got a pretty good working model of a basic lag compensated structure here. So I'm feeling pretty good about it, and I'm going to push this out. So if you're just interested in the project and you don't care about watching the video, please like and subscribe or follow to support. You can buy a shirt if you want, and just go ahead and clone that repository, and you can build your game off of that. I plan on actually building a game off of it and maintaining it over time. So any improvements or anything that I make to it over time, I'm just going to add to that repository. So keep an eye out on that if you're interested. Okay, I want to pull open my Netfox example project that I had worked on a long time ago. All right, let's open Netfox, my Netfox. Uh-oh, why is this showing changed? I didn't change anything. So let's see, where are we at with this? Please don't break. Yay, all right, so this is a Netfox lag compensated game using Bracky's base tutorial. Why can't I move? Why is it? Oh, it's like catching up. There's a little bit of bugs in that Netfox, but every now and then you'll see a little quirk. But it is synchronizing using lag compensation. And I could deploy this on an EC2 server out in the cloud, and it would probably look pretty close to this. Yeah, so Netfox will synchronize time. It's one of the key things with the lag compensation is keeping time between your authority and your other peers. All right, so how do I add Netfox to project? Probably not going to get terribly far with my Netfox implementation today. I just want to get it, kind of installed and just like get the basics working. So I think I need Netfox and Netfox internal. And if we look under, how do you see, is it project settings, plugins? All right, so those are the 2 Netfox plugins I've got in my example project. So we're going to copy that, and let me just see. I don't think this is a real change. So add movement state machine. I don't like how there's a change here. Guys, did I change anything important? I really don't think I did. I don't know why. Whatever. So let's just reset it to the commit. All right, and then it's gonna make me reload. Oh, I did, and it didn't work. All right, so be careful with certain things, right? It didn't work. Yeah, so you remember this should be synchronized. So I just uncommitted that change That's what that change was in the scene, and it didn't work. It didn't actually fix it. That's scary. Like, this should be resetting to that. This commit should have made that come back, and it didn't. That's scary. Why is Godot not able to, I don't know why. Maybe I had to reload the project because it's running. There's a couple other reasons why, but okay. All right, so we have that back on track, and it's not showing as another change, so we know that's good. But let's create another branch. Let's just call it Netfox lag comp, and that way, if you are following along and you want access to this project, it is available on my GitHub. This project. I do push out the updates, but it's under the branches. I think the current is under add movement state. That's what's out there right now. And whatever changes I do for Netfox, I will add that to this branch that I just created. And I have that link on this stream if anybody needs that. Okay, so I want to add Netfox to the project. And I think we can just go under asset lib and type Netfox. And I think we just need this guy. Norway is his P2P plugin. And I think you can create your own relay server for it. I think it's a relay based server, but he has one running by default. So I don't know how long he can afford that. I think he's just paying for like a random relay server, just like a Linux server. And he's got this whatever the back end is running. And this is like the plugin for it. So if you want P2P, I think you can do that with Netfox. So it's pretty cool that he's got all that working. Okay, so we're at 1.8. And I think we're okay. All right, let's just download it. Okay, so it automatically installs internals as well. So that's good. That's what we want. It just crashed. Oh, God. Yeah, let's reopen. It's not going to reopen. Okay, so I'm going to have to open it manually, and let's hope it didn't break something or corrupt something. Project settings. Let's see, did it work? Don't forget you have to click enable. You have to click enable. And that's probably why it crashed. And I'm getting errors. But it looks like it's installed. Yeah, hopefully this isn't some bug that just got in here. Let me see if I can save and run it. And I'm gonna do a reload current project. I make bad games, by the way. Okay. I'm not seeing the errors. Yeah, I think you have to enable them. And if I was being smart about this, I would be following his documentation. So if we go to my video on that, and we go to his documentation, which is here. If we go to install, let me see, enable that. Yeah, you got to, after you install, you have to enable it. I'm just making sure I'm not forgetting some of my setup. You can use Norway, and he does provide a host for that if you're interested in testing that. And then if you don't want to use his backend server, you can create your own and use the, I think you can deploy the whatever node project that he's running as a backend. Yeah, so somebody was asking about this, and I was talking to it a little bit in the last stream. So I guess Norway can help with NAT punch through. There's a lot of people looking into that, and I think he forked this off of something. Yeah, I'm not sure what's going on. I don't know the whole hierarchy and history about this, but so I think if this is doing what I think it's doing, this is pretty cool. So it looks like there's two parts to this. There's the part that's in your Godot project, which will help you do the NAT punch through setup. And then there's the part that you host, and it can act as a relay. Like I think you have to host it somewhere. Like and it only relays UDP traffic, so keep that in mind. So that's pretty cool. So so it looks like you can run like this as like a Docker container somewhere, and you can host it, and it'll act as your relay for your game. I haven't played around with this, guys, but this seems really powerful, and I think a lot of people were asking about it. So that seems to be a pretty hot topic. So maybe I should do a video on that someday and walk through that. I think that would be fun to see how that works. And if you're not doing that P2P setup, which I'm not necessarily designing this project to be P2P. I mean, you can adjust it, but I'm trying to do a dedicated server approach. So I don't really care about this side of things. And I'm just trying to go through here and make sure that I have everything set up correctly. So I think we're going to do responsive player movement. And in order to do that, you have to move your input into a special function that's called gather. Right. I think that's what that was. Cat hair all over me. And if we go and look at the old example project, let's see, multiplayer input. So in here, I do a network before tick loop, and then you gather. I guess this is like the first time you want to run your gather function, and then oh no, you're connecting it. You're connecting the network time to call gather. So that network time will gather your inputs correctly in step with the correct synchronization or synchronized time of everything. And right. And then you just update input. Sorry. It just gathers the input direction as needed. So I think what I need to do first is kind of set this up. And then we'll look at, I should look ahead just to make sure that this is even feasible. And then we'll look at how to do the lag compensation setup, which is this rollback tick. And where is that? Is that auto setup, or do I have to do something with that? No. Okay. So under the player, you have to have a rollback synchronizer. And then you add a, hold on, let me check. Player input. I just talked to that. And then I'm going to add a rollback synchronizer, and then I'm going to add our player root. Then we're going to just synchronize, I don't know, I guess orientation and position. I guess you can do transform, but I'm not really. Okay. And then I also need to synchronize the inputs in there. And then the tick interpolator. What was that doing again? I'm like trying to remember all my research that I did. Let's see, tick interpolator. Oh, okay. So this is what smooths out stuff. So this is so you don't need this. This is just going to smooth out that movement. So he adds another set of layers of functionality so that you can smooth out the movements. And then state synchronizer is just synchronizing stuff, right? So I don't think I need that because I'm using a rollback synchronizer. I need to go rewatch my video on this because I think I explained it all in that other video. So state synchronizer is like making sure the NPCs are correctly synced because there's like movement to them. So you're not synchronizing player inputs and trying to apply the rollback stuff to it. So this is just like a separate node. I used that when I was synchronizing my bad guys in this Brackeys demo before. Yeah. Okay. So I think if we just try really quick, maybe I can just get a starting point on it, and let's go find our inputs. Where's that at? Oh wait, I think it's under state. So it's not under rotate. I think it's this function. But no, where's the inputs though? What did I name it? It's not networks. It's not camera input, player input. There we go. And that is this guy. Okay, so here we need to add ready function. So this is our player. And I'm just gonna copy paste what I did before because it worked fine. And we need a gather. We need a gather function. Oh, I didn't copy it. And so instead of physics process, right, we don't use physics process. We use this gather function. And did it have delta in it? He doesn't have a delta because this is like handled differently. And that's just how I do it there. Make sure tick interpolator doesn't care about, but we'll need a rollback synchronizer. Okay, so we have our gather function established, but then we need a rollback synchronizer. So let's do that and do rollback synchronizer. I see it right there. So we're going to select rollback synchronizer. And I don't think I need to put it anywhere special, but I'm going to stick it right, not in the player input, but next to it. And we're going to assign the root to the player object. And what properties? Well, so right now I'm synchronizing position, and we're not going to want to do that anymore because we're going to use our rollback synchronizer to do that. So let's undo that for now. I'm going to set it to off and never. And then orientation, I'm going to leave that there. We're going to do one thing at a time. And I think we do, let's select a new state. So we'll add an element and it'll just kind of do it for us. And I think I can just do the path notation and then position. And then our inputs is going to be like input dir. Well, how did I do that again? Input colon. So mine is player input, right? Which is this script. And then it's this input dir, which is a vector. So we'll just add a new element and do player input. And that's our node. And then it has the player input is this class name of the script, which has this input direction. Let me bring that up a little bit more. And then I don't think we want to synchronize this input direction anymore. So I'm not going to worry about jump or run right now. So let's just change these to not. So input direction is not going to be synchronized like we typically would anymore because now we're enabling it to be rollback enabled, setting it to be rollback enabled. I can talk clearly. And our position is what we're going to enable to be rollback synchronized. And the player input direction is what we're going to base it off of. Now, I'm hoping that these still work, even though I'm not running inside the physics process. I still think they'll be applied correctly because this still is a loop that we've added into our network tick. Okay, so now that we did that, I don't know why I have all this stuff open. Okay, so now that we did that, let's see what else do I need to do. Let's go back to the docs really quick and look up the rollback synchronizer documentation. Okay, so we did that. We've got some stuff that we are synchronizing, and we need to add a rollback tick to enable the synchronization because that is how we make it rollback aware. So in order to do that, let me just copy it from my existing code. Okay, that's handling some use cases that I don't have to worry about right now. And let's scoot back to our project. It's under state. So I'm a little nervous about putting that in my state, but I think we're okay. Let's put that there. And then instead of, I think I'm passing it in from the player object right somewhere. Okay, so I just rotate the player and then I'll probably have to make that adjustment. So if I don't want to put it in the top of the state, I may have to turn this, may have to make this, put that rollback aware thing in this actual script here instead of into the top level. Because I think that's what I did with the other one. I think that makes sense. So yeah, so then let's try that. Let's so instead of process physics, it's gonna have to be changed to, oh, that's getting called from the other way. Actually, so if I move to the top level, it would be this. We would be replacing this. So if I put the rollback tick function here at the base of our player script, which I think that makes the most sense. This is going to assume that it's the authority, the way that it's set up. Like, I don't think I need this check here. But then I can just run, I think I can just run that. And then this rotation will have to be handled. I might have to handle that slightly differently. So for now, let me just try to do, let me think it through. So if I stick this here, I can't remember if that's allowed or not, the authority thing. So he's got his movement applied here. And then each state will just synchronize the position. So I think that's the way I want to do it. But the way that we're gathering inputs is not really working for me. So that's in state. Okay, so movement. So I don't know if we need this anymore. So for like move or jump or, oh, you know, I said that. Okay, it's coming back to me. I said that we probably may not need to use process if I said that. All right. So I think I had like a gut feeling about that a while back, and that ended up working out pretty well. Okay. What this is going to mean though, okay, so because, so okay, so I use this state machine. This state machine is based off another developer state machine, and it was a single player game. The Shaggy dev, thanks for the code. And but because I'm using it in a multiplayer sense, it doesn't make sense to do the way that he was, to handle the input the way that he was handling it. I ran into that as I started, you know, clearly I'm not using this unhandled input, and I'm not using process input on any of my states. Like I don't even have it because it's handled a little differently, and it just didn't make sense to have it. So this is going to get simplified to this. I feel pretty good about that, but I still have this client side stuff that I don't like. So I don't know if I can do this and then just run it in there. I'm going to have to refactor this. I don't like how this is working right now. But what we'll do is we'll just get rid of this. So this isn't needed. Just going to leave that note. And then I'm just going to comment out the whole process physics. And I don't know if this is going to work right off the bat, but because we're using rollback, and I'm probably going to add orientation over here, right? This guy. I'm probably going to add it over here. I probably won't need to do this anymore. It just, he may not rotate correctly on the client side, but I think we can just try it. Let me make sure there wasn't something else. And I'm not going to add the tick interpolator just yet, so it's going to look jerky. But yeah, so here's the rollback tick, and I don't see anything else in my example project that would allude to me needing other things. I think I have it set up correctly. Yeah. So I got my rollback synchronizer. I've got the position of the player synchronized. I removed the position synchronizer out of here. I'm concerned just having it there will cause a problem, but I don't think it should. I don't think it would. And then I removed the replication of input direction as well. So we had to turn those off because now we're grabbing them in our rollback synchronizer. So let me just run one and just see if I broke it. Yeah, you can see the little bit of jerkiness to it. I think that'll all get smoothed out eventually, but it didn't break, right? Yeah. I think something is going to be broken though with the rotation on the other peers. So let's run the host, and he's in the game. He's stuck in the walking animation for some reason. I think that has something to do with the initial synchronization happening. So it's still working with that many clients. Let me try it with the third client. Okay, so I think so the jump isn't using rollback. It's not using a rollback aware property because I'm not synchronizing it, and I think that's yeah. So I'm using both properties, both methods. Like I'm using my synchronization for the jump and the rollback. Man, I can't stand how Sublime Text is open. But let's try to smooth out that now that works. I mean, that was pretty easy, guys. Now you have lag compensation. I mean, that was like what took me 10 minutes. So let's just try to add a tick interpolator and then see if maybe that'll smooth it out. So we select our root, I think is our player. And then the properties we want to smooth out, which I believe I just say position because we're just synchronizing the position of the player under rollback synchronizer. So I think it's just this object. I mean, property. And I'm going to double check with our example project. Yeah, so I was synchronizing global transform in the other one. And if we go back to mine, it's enabled. Yeah, I'm just going to do position. Let's see if that's going to work any better. It's actually a lot smoother. Like it's not doing that. I thought maybe it was something to do with the setup, but it is not. I mean, there's some jittery, like when he's turning a little bit, but I'm wondering if that's because of my weird stuff, right? So let's just try the third guy. Everybody's synced. That walking artifact has something to do with how I have it currently set up. He's not synchronizing his rotation on all the clients. He's only synchronizing it on the two client peers, not the host. This is the host in the bottom. So if you watch, the rotation is not correctly. Oh, well, it's working on that one. It's going to this client. It's not working. This is why you always do 3 tests, because you got to make sure that your code is running correctly. So this isn't, so I think this is just an artifact of how I've got it set up, guys. So I don't think this is the right way to do this. So we had our physics process where we were like our old way, our non-lag compensated way. And I was running process physics to move the player, and we synchronized position. And then I call for non-authority peers, we just called this physics process to rotate the player. I don't think that's going to work in this setup. And the reason why is the way that his lag compensation is set up is that I believe the rollback tick function is going to be executed authoritatively on your server, but also it's going to be executed locally first on your client. So this doesn't make sense to run this. because he kind of handles that for you. You have to think about it differently. You have to think about, I'm going to put my deterministic movement code in this function and it just will magically work. And that's not how I'm doing it here. So this process physics client and the state machine needs to be refactored. And I have an idea on how to do it, and I can try it really quick. So process physics client is just a function that I invented that applies rotation everywhere. It's literally all it's doing. So everywhere I click, that's all it's doing. So let's just ignore that for a minute. What we're doing there is we're just rotating the model, this military male guy, our little model guy. And I'm thinking that wherever we do this on the server, which is in our move player code, I thought I was calling, unfortunately, I am calling it inside the process physics, which is inside this. So whatever movement, whatever state you're in, whether it's fall, idle, jump, or move, and right now I'm just in the player class, you call that machines, that current state's physics process. So if in the case of move, it just calls here, and then we rotate our player, and then we move the player. So that kind of tells me that this isn't needed anymore. I think I can just remove this. But then I have to synchronize orientation, right? Or maybe not. Hold on. Yeah, I mean, I think I have to synchronize something, or maybe I can just synchronize global transform of the model. Because if we look at our move code, move is like moving and not rotating. But if we leverage the current rotation, let me get rid of this. And then when we rotate the player model, we're rotating that model, the player model, right? So we need to synchronize the player model's global transform. Okay, so I just talked myself into it. Okay, so wonder if I can do, I think this is called military male. Can I do that? I can't do that. Okay, military male. Think I can do global transform. I really hope this works. Because that would make this really easy. Because what I'm doing on the server is I'm setting that authoritatively, but our client should also be setting that. But the client would need access to this orientation variable. Maybe not. Because the server is going to know the camera input, but the server doesn't know it yet. Sorry, guys, I'm just talking this through. So I think I need to synchronize the camera input. I'll open up the input script. I think I need to synchronize the camera inputs stuff as well. So how would I do that? Like this rotation basis. So I think that would have to be synchronized. So I wonder if I can do camera input, and then this line of code. I don't know if this is possible, right? So camera input, I want to synchronize camera input because the reason why you want to synchronize it now is on our server authoritative side, we need to have access to it right here. I think one other variable too. Yeah, the base quaternion. So I'll need to get that too. But because that happens on the client as well, our rotate player scripts during the move will have to run on the client as well. So in order to make it deterministic, in order to have this run the same way, right here through this physics process, I would need to synchronize this to the server. I think that's how I would do it. I just don't know if this is going to work, because what we're doing is we're synchronizing the basis of that rotation, the camera rotation object, and then we need another one for up down, which I got to grab. And that's considered an input because it's from my mouse. And what that does is it applies transforms to our 3D model on the server, right? In our, where is it? In our move player script, right? Somewhere in here. Yeah, through this camera basis. So it applies that and it moves the player in the direction of that. So hold on, no. Rotate player is called before that. Rotate player is called before move player right here in the machine. So we rotate the player and then we move them. So when rotates hit, yeah, it actually will move the model. And what we're doing is we need to synchronize that, and that's why I'm adding that there. So I think I'm going to need that as well. Man, I hope this works. So in order to get it correctly, I would need this. If this doesn't work, then I'm quitting and never coming back to this. I'm just kidding. So let me do camera rotation. Nope, it's not rotation. I think it's camera mount. No, it's just all this. Oh, and you can't really quaternion. This returns a quaternion. So I need to be able to like return an output of a function. Can you just get can I do this? I mean, this might get us there, but how do I get the quaternion out of the basis without calling? Like, how do I synchronize that? Because, well, how am I doing it now? Okay, hold on. Something's off here. Hold on. So if I'm using a camera, let me look at the camera input again. What am I synchronizing? Okay. All right, hold on. I think I went off on a bad tangent there. Hold on. Because I'm synchronizing the rotation of these two objects, I need to synchronize those two objects maybe right here. So it was camera input, camera mount, rotation. So I think it's not this. I think it's camera input, camera mount, rotation. And then it's, what was the other one? Camera rot, I think I called it. Camera rot, rotation, camera mount, rotation. So I think it's these that I need as inputs from the player. Because this side is saying, what are your inputs from the client? And that's what the inputs are from the client. And we synchronize them. We do some calculations on them and then we synchronize them. But yeah, and then we use those. How does this actually work? I'm like almost wondering how my code has been working. I know that's not very comforting, but so that's not what I was thinking. Okay, camera input. I'm just not sure I was even using it to need to synchronize it, because I'm not actually, unless somehow, because I'm using the camera inputs function on, I think, I was synchronizing rotation, and I'm wondering if that even had any effect on this at all, unless rotating it just updates, this behind the scenes. I think, okay, sorry, I think that makes sense. All right, so if I go back to where I was a second ago, we process physics, which just calls process physics on any current state, and we rotate our player. The rotate player calculations use our synchronized inputs like camera mount rotation to determine where to look, where to turn the model, I should say. And then we also move the player. Whoops. We call it move player. And I just have it in the state-based class, by the way. And we pass in that rotated basis of the camera to give us where we're going to look. And yeah, I mean, we're using input direction, which we're synchronizing, and then the camera basis in the previous calculations here. The camera's rotation gets updated on the client, and then that is synchronized through these. And then we have access to those variables on the server to apply it to model. So this should work unless this orientation, it should work because I want to, whatever we end up doing to the model, it should just be part of this global transform. All right, whatever. Let's try it. I've thought about this enough. Okay, so our host still works, which we can always assume is gonna work. Okay, he's rotating, so that's one good thing. And he's walking and rotating. Okay, he's jumping, which is a little buggy, but that's just part of the process. I'm sure there's a bug there I need to fix because I'm not actually doing lag compensation on jumps yet. Okay, and let's try the third client. It's like there's like a bug. It takes a second to synchronize the player. Guys, I think it's working. I think it's working. Let me try all three clients again. He's walking around this dude. He's walking around this dude. I think it's working. And then let me try the top client. He's turning. I think I did it. I think I got it. I think that's working. And there's a little jitter with it, but I think what we'll do is we're going to interpolate this. I think we can interpolate that. And I think that might smooth it out. So this is our host, client peer 1, client peer 2. Okay, so this is a guy there. It takes a second to synchronize the time. And I think that's why you'll see him like jitter. Okay, well, he seemed a little jittery there for a second, but I think it smoothed itself out. I think it needs to like warm up. I don't know. There's like a couple little things that maybe, you know, we can improve with this, but I mean, this one seemed to work right away. I think this is working. And let's do a quick test just to make sure. Let's put this back to that, and we'll run 3 instances. I don't think we'll need that anymore. Synchronize. So I removed that, and let's just check it really quick. Local test. Yeah, it looks like it's working as expected. Yeah, okay. Cool. All right. So I think we're good. Ignore that little animation glitch. I think that's just something in the timing that I need to fix because this is the first time we've added lag compensation. So there is a little bit of a animation problem, it seems like, with the state not being synchronized. So that could be another thing that we look at in the future. But yeah, we don't need this orientation at all. So let's just delete that. And then at that fact, we can actually just delete player synchronizer because everything we're synchronizing is the rollback synchronizers of the position and the global transform, which handles the rotation. So I think, and then this is just like we're interpolating those things so they're smooth out. So I think what we do next is we fix that animation issue. And how do I remember to do work on that? Let's go to the player state. So yeah, that didn't work out, trying to rotate the base object. So what we'll do is we'll look at adding jump and run to lag comp model, lag compensation, and then fix animation bug where it animates walk on other client when player is idle. Okay. All right, so I'll clean this up. I'll remove out this stuff, and then I'll push out the code soon. But yeah, I think we've got a good start for the lag compensation, and I'm going to test it out in the server, and hopefully that works out. So the first big refactor, I guess, that I want to note right off the bat is I had to move away from determining the states inside determining which state to move to from the individual states. So like idle, jump, move, and fall all had conditions in them that would determine which state you had to go to. I had to back away from that technique. And the reason why, without getting too technical, is when you have a rollback that runs and executes, it needs to, all the parameters need to be deterministic so that when it rolls back and tries to run through to catch up your client, because right now, like when you're moving, that's your client prediction. And then eventually you'll get correct states back from the server that'll try to reconcile with your client. And it basically does this rollback mechanism. And if those rollbacks don't operate correctly, like with the same deterministic setup, then you're going to have problems. So what was happening is what it does is it takes your inputs and it passes the inputs back into your movement functionality through this rollback tick function. And if those same inputs produce a different result, then you have a problem. And that's exactly what was happening. I was getting inputs during the rollback, during the reconciliation part, and it was producing the incorrect state. So what was happening is I was getting an input for standing still, but I had already started moving. And if you got a standing still input while you were in the move state, it would flag that right here. It's kind of commented out right now, but before what I had, it would actually flag that as being still, and then it would kick me back to idle state, and then it would still, and then the next tick would say, hey, your next input was move, and then it would kick me back to move, and it kind of did this like back and forth until it eventually settled out, and it was causing jitters in the move and jitters in the jump, more visible in the jump, and it was more data jitters that it had printed out. And if you're interested in that, or if you ran into that bug, let me know, or if that issue, and we can work it out in the Discord, or jump over into the Netfox Discord. But anyway, so one of the big first things that I had to do was remove all the state determining logic out of the individual states. And that is a pretty big refactor. So if you've been following along up to this point, hopefully you're not going to be too upset, because that really moves away from the original state machine setup that I had. So what we had to do is, as in the first part of this video, what we did was we would just call to this process physics function, and then the corresponding state, let's just say jump, would, if that was our current state, the physics process would be called. And then once you hit the ground, it would kick you back out. Well, I'm not doing it that way anymore. I removed the returns of the states off the physics process, and I just run everything. I grab your input, like what you're actually doing, like from the current state. So if the current state is move, we get your inputs off that brain, that current state's brain. And then I created this determine state function right here. So if you're following along, let me just see if I can bump up the text a little bit. So if you've been following along, it's really similar to what this is doing here, where we determine, like, if you're on the floor, if you're not on the floor, you must be in falling, or if you press the space bar and you're on the floor, then that's a jump. If you hit a move input, if you push W or whatever, that's a move state. And if you're not doing anything and you're not moving, that's idle. Well, I just moved all that to this function. And one of the corrections that I missed in the last stream, or the first part of this video, is this force update on floor. When I'm getting the current state based off input, you need to determine whether or not you're on the floor to see if you're in a fall state, or if you can jump and move around on the ground, right? Well, there's this caveat with Netfox that I'm going to pull up if you guys check out their documentation under this rollback caveat section under tutorials. If you look at character body on floor section, if I can bump it up. Yeah, so this says that there is some, I guess, problem during the rollback where if it's doing a rollback, it won't actually correctly detect that you're on the floor. So what we do is we add this little workaround function call here. You just copy paste this code in, and it just sets your velocity to 0, performs a move and slide. So kind of just does a quick pause during the rollback. And this will happen within like 1 frame. So it's not like it's going to affect your player or anything. And this right here will actually give you a real on ground detection. And then we just set the velocity back to where you were, so that if you're moving or falling, that velocity that during that rollback will be corrected, won't be incorrectly detected or used as calculation. So we run this before we do a on floor check. And if you're not on the floor, well, then you're in a false state. So we have a false state. And if you are on the floor and you hit jump, well, then we set the jump state. If you're moving, that's the move state, obviously. And then idle if you're standing still, or basically else. Now, this isn't by any means a end all be all solution to state movement mechanics. This definitely has room for improvement. For where I'm at with the template, I think it works fine. And I'm sure there's going to be some improvements needed to this over time. And as I discover those, I will be happy to update them. Or if you find an improvement or anything like that, please do create an issue or make a pull request, and we can, work collaboratively on this 3D multiplayer template. So that was like the first big refactor there, is to move away from, the state-based, individual state-based state determination. So then if you do have a state that hasn't changed, well, then you just go ahead and continue working on that state's process, whatever the brain is, like, for lack of a better word. So in this case, if you're an idle, the only thing you can really do is get the rotation inputs and rotate the player. If you want to move, if you're in the move state, you can rotate the player and move. And if you end up jumping, well, then that kicks you out to a jump state. And I actually allow for a little bit of movement, but I have like an annotated or a modified jump move speed that you can slow or speed up the player if you want, based on, it's just a modifier. So you don't have to put that in there if you want them to be able to move at the same speed they walk, but I wanted them to move a little slower in the air. So that's what that does. So this will jump them up in the air. And then once they're in the air, this is going to run for probably like 1 frame, and then it'll immediately go to the fall state, right? Because we are not at the floor at that point. So we'll switch to that new state. And oh yeah, by the way, if it does determine that you are in a new state, this is where we just leverage that same change state functionality underneath the state machine, which the only big edits I had to do was, I'm now referencing a current state that's in the player object. That was like one big one. I just added a current state field. So we're referencing that instead of just instead of this state machine's right here, this current state. And I think that was pretty much it. We still can just call enter. So we exit the current state, and then we enter the new state that comes up that'll get set here. So it's pretty much the same. Not too much has changed. I was using an RPC in the previous version of this to communicate a state change to the client, because we're using this like lag compensation rollback model, we don't need to do that. We don't need to communicate that anymore. So that was like just to compensate for, a naive solution where you have to wait for that round trip for your player to move. This was able to communicate the state change from the server. So while I'm in here, I'm just going to do a little bit of cleanup and just remove that. If there's another use case where we need that in the future, we can add that back in. But right now we don't need that RPC call. And just while I'm in here, the other change, the process physics is just looped. Nothing's changed from the last video. Obviously, I just, I'm passing in the, is fresh and tick, and then the frames just to get some additional debugging. But this is just called in a loop in this rollback tick. And that calls to here, which subsequently calls to the current states version of that, which is the brains of the current state, which is right here. And that's respective for each state. All right, so we no longer are returning, like I said before, we're no longer returning the state that it needs to change to, so we don't need any of this logic in here that would change the state. So I'm going to remove that. And I'm also going to remove the current state and the starting state out of here. We don't need it. And I believe that was most of what was going on in this state. Let me just check back to make sure I got everything. Yeah, so we've got this rollback tick function here, and it captures our current movement input. That's just going to handle like, let's just go to it so you guys can see it. That's just input direction. And if we just do a quick refresh, movement component was set up here, was passed in when we initialize this class. And yeah, what is it? State. Yeah. So each state, it's actually in the state machine. Each child, we just set the move component, and the move component is passed in from the player. And what we do is in the state function, we just have this movement wrapper, this get movement input wrapper to grab the input direction, which of course is under the player input. And this was all set up in the first section here. And of course, we just set, is the player moving? Is the player jumping, pressing jump, or is the player running? And we just grab those at the same time, basically. So if we go back to where was I think I was under player. Yeah. So we just grab whatever version of get movement input is. Like, I think there could be a use case where you might want to override that. Like maybe if you want to annotate movement or prevent movement. So I just left it to be based off the current state. And if we grab that current state's movement input, like again, is just the keyboard and mouse, we run it through this determined state to see if we have it. Down here, I grab the get jump function, and I guess we could have done the get movement state in here as well, but I wanted to be able to do some additional logic with it. And now that I'm looking at it, I realize that we probably don't need to do it this way. I can actually just move this down into that. I think I had like a debug statement earlier, and that's what was going on with that. Or hold on. New state. How did I have that really quick? Actually, no, I think I need it here because the current state hasn't changed yet. And you need to be able to handle whatever the current state is, movements input, because if, let's say, like your current state's idle, but you get a rollback that's in move, what it's going to do is idle. It's going to just give you the input, right? Which is right. Okay. I'm just trying to remember how to explain this. Yeah. So just to do a little quick detour, input direction, input jump, and run input are now added to our rollback synchronizer, which we started earlier in this video. And we went ahead and added them all here. So they are being synchronized. These four things here are basically the four things that drive our player's movement and allows for that rollback and synchronization and lag compensation. So when we're currently moving, or if we're currently pressing a button, we get the movement inputs, and the input movements are just like right now, it's the same for everything. Like you're just it's like -1, 1 for moving backwards, and like 0, -1 for moving forward, or whatever the vector 2 is for that. And then we go and calculate which state those inputs should give you. So when we do a rollback, it's going to give us these parameters again for that specific reconciliation tick, and it will provide the corresponding input direction and these four things for that specific tick, like I just said. And then we run it through this determined state first to make sure that we're in the correct state for that action. And again, like I said, this may not be the perfect solution for maybe whatever use case you're working in, but it looks like during my experimentation, this seemed to allow for the correct rollback functionality without any jitters or data jitters and flipping back and forth between our current state and our reconciliation. So this is what I went with. This seemed to work great, and so far so good. Okay, so if I circle back to the state machine, I was able to remove a couple things out of here. Process frame we never used. That was just from the original example I took from the Shaggy Devs project. So we don't need process frame anywhere. Let me just see if I can remove that really quick. Do some cleanup on here. This is, again, that is the library. That is not AMI code. Yep, that is just some other stuff. Save that. And I believe, yeah, process frame we can remove out of here. And I know we're going to remove process input as well. So let me just, we didn't have to leverage process input in a way that would make sense for this because our inputs are through this rollback synchronizer. So let me just make sure we don't have any extraneous process inputs. So we got one here, and I think that might be process input. Yeah, there was one under idle that I had in there from when we first started working on this. And is this, where is this one? Yeah, you can see I've got some notes there to remove it. Unhandled input is also, we're not using that. That was also from the original example. And I think that was it. So let me just double check. All right. So then the other thing I wanted to remove was I created this process physics client a couple streams ago as a way to synchronize the player's rotation of the model. Of the model. And so the player's model, that is this guy. But we're not going to do that anymore because of this rollback implementation, this lag compensation. So we can let's just search for that really quick to remove any usages of that. I think I've already got it commented out everywhere, but I thought it would be helpful to show you guys because it was added in a previous stream. I wanted to remove it on stream so that you had a pretty good idea of where those things went. Okay, got a couple more. And I can remove this state conditional out of move because that was just there to give you an idea. And we can also get it out of idle. And there's also the process physics client there. And we don't do anything in enter right now. So let's just remove it. And then I think our last bit is here. All right, great. Okay. And yeah, this is just some leftover logic while I was doing some experimentation that we don't need. I think I got everything cleaned up in the player function. And let me see, rotation synced on. Okay. So what we had to do was, because we moved to a player-based player level script state determination, we also had to import get a reference to all the states. So under the player object, drag over each of the respective states, and our current state is just defaulted to idle, and that's where we start at. So that's fine. We can leave that there. So I think we've got our player script pretty much wrapped up. And let's see, we've got player input, which was good. Player is good. Move, jump, idle, fall. And let's talk a little bit about what's going on in the just some debugging stuff I had there in the state script. So I think from the first section, what we were doing is also remove that. Let's just add gravity. So rotate player model. Okay, so in our idle, basically every state has the ability to rotate player. I'm allowing it for this template. I had in this rotate function from the first section or the past videos, I've actually been using this logic for a while, and I discovered that there's a problem with it. So if you're using my rotation camera logic that I had broken out into its own method, definitely pay attention to this because there is a problem with it. It's going to be hard to see in this mess of comments, but there was a conditional here that said player look at target, and it was never not getting hit. It would never go into this else section where we were getting camera based quaternion and applying a different set of logic. This was from some old 3D game that I had made a few months back, and I just kind of copy pasted it as I went and never really checked to see if there was any technical debt with it. So I had to completely refactor this whole function, and it ended up being just a few lines of code. So the first thing you'll notice at the top here is we have this camera input reference, which again, all the states, this is the state class, so all of our states have access to that. And our camera input class is just over here. And I'm grabbing the camera basis. And before I was grabbing camera rotation basis, but you have to remember that when we're in a rollback synchronizer, when we're using that type of algorithm with specifically Netfox, we have to be able to capture the things that need to be rollbacked and processed correctly, like movement and actions and maybe where you're looking, right? I thought it was important to do that. And I didn't really have a property. Like I think in the first section, I was trying to grab the rotation of our camera, like our camera mount and our camera rotation object here. But as I was playing around with this off stream, I realized that wasn't going to work. It ended up just being a little too kludgy. So what I ended up doing was I settled on creating a camera basis object that we could successfully use under one of our inputs. So moving the mouse will adjust our camera basis. So in the camera input class, under the ready, you have to implement this Netfox before tick loop, connect a signal to a gather function. It's just common practice to name it gather based on the docs. And in here, I'm just gathering the current camera rotation basis. And you can see it's just right here. Before I was using the camera rotation object global transform basis, but we don't need to do that anymore. So let me just clean that up. And because we're not using that conditional anymore, let me just pull state up. In the else condition of our, rotate camera, we were using it, right? Let's get rotation quaternion. We're not using that. Again, that was left over. So I'm just going to clean it up and remove it because I don't like keeping stuff around that I'm not really using. And if we need to reference it, we have it committed in GitHub and we can reference it there. So rotating the camera rotates a mount object and a rotation node, respectively. And that is based on our mouse movement right here from this input event. So we move the camera, and wherever the camera ends up being, I just capture that camera mount's global transform. And I just set it to a basis, and then I can track the basis in my rollback synchronizer so that if there's any rotation issues, we can track it there. Or if there's any need to roll back is what I should say, we can track it there. So that said, this is the cleaned up version of the camera input. If we go back to the state, I was doing all this setup here and none of it was necessary. So I'm just grabbing the camera basis for now, and we can basically just clean this up. And while I'm here, let me just clean it up a little bit. And I'm using that camera basis. I'm just creating a local variable for it. We grab the Z so we know where we're looking. We don't have a conditional here anymore, so we don't need it. But we, again, take a from and to based on where the orientation, which is just something that we track on the player's object. And then we just rotate them based on this where the camera ends up being. So that's just from and to. And then we do a spherical lerp on that. And that gives us the basis that we use to set the rotation of the player model, which is this military male over here. So all this code, this is just debugging, so I'm not even going to mention that. But all this code before, where I had like a conditional and there was like a different set of parameters we needed to track, we don't need that anymore. So I'm just going to remove it. So our rotate player function has been simplified to this right here. It's just get rotation quaternion for those that are actually trying to follow along. And yeah, sorry for going so fast on this. This is just going to be a review. I wasn't able to do this on stream. It just ended up being too complicated, but the project will be available for you if you want to check it out. I just got to do all these changes and push it out. Apply a player rotation client. That was, again, an artifact from when I was streaming a few weeks ago on rotating the player. That just can completely get chunked out. So if you're using that, you can get rid of it. Because we have to really approach this rollback and lag compensation from a different perspective. I just removed the return on there because we're not returning physics process anymore. And let me see. I wanted to mention something else. So there is a slight caveat with the rotation. There is a slight jitter. And let me just take a break right here and let's do a build just creating a Linux build, and let me push it out. I tried to do this at the end of the last stream and it just stopped uploading, and I just realized that my computer just decided to switch networks on me, which was a little weird, but it ended up being like the 2.4 network, so it was just like crawling slow. So let's just join. All right, so he's in, and he, it's pretty smooth, right? So you can see him tracking there, and I don't see any issues. Again, there's a dedicated server running somewhere, and these are clients. So I don't have a host. This is just two clients connected on my computer to that server. So you can see that the movement's pretty good, and you can see the turn. But if you'll notice back on the first screen on the left, there's a jitter here in the rotation. I'm not 100% sure what's going on there. So while I do have the rotation working for the most part, there is still a little bug that I need to work out. So if you end up finding a solution for that, or whenever eventually I find a solution, I'll let you know. But as far as I can tell, I'm tracking everything correctly. The transform of the player, which is just the overall transform, and the models transform as well, which is this guy right here. And if you take a look at the tick interpolator, I'm also, these are just like things you can smooth out the transform of the player and the transform of the model. For some reason, it's still not working. I don't know. Maybe I need to add velocity to the tick interpolator. I don't know. I haven't been able to figure that out, but I'm sure it's not that huge of a deal, and it's just something that I need to iron out. So now that we've said that about the model, or the rotation, let's take a look at our move player code. I had this camera basis in here that was, I guess, being used for some, I'm not even sure. I was like doing this extra rotation around the X axis of the camera of some Euler, and I felt that was redundant. After I was like doing some research on this and debugging it, it didn't make sense to keep that, and I was able to successfully remove it. So whatever this line was used before, it's no longer needed. My camera's basis is calculated in a way that's improved. The movement input is passed into the move player function now. That may or may not have been an improvement from the earlier section or the earlier video when we moved out this move code. So move player, if we go to move, is just move player, and I pass delta in the movement that we get from that current state. So that's all that's going to be, and I just capture it in a local variable there. So then, we apply our direction. This hasn't really changed at all. The camera basis just is based off our camera input, which of course we hold at the top here. And so we're grabbing that camera input in both our rotation and in our movement player code, because we need to be able to move in the direction that the camera is facing. Now, if you need to adjust it, maybe your game doesn't use that, then you're going to have to go in here and refactor this direction calculation to work with whatever your game requirements are. Here I have a run modifier, which is nothing new. And I also noticed that I was performing this horizontal y equals 0. And that was like, I believe, in an effort to keep the player from like staying upright. And now that I just said that, I believe my calculations for the rotation changed. Yeah, whatever I had down here originally, I changed it to this. And that camera mount is like the top level. I believe it was using the camera rotation, which is a lower level node, because these are nested, and it required me to perform this fix. Well, now that I have it set up in this way, it's not necessary anymore. And I'm not doing this lerp between the position target and the horizontal velocity anymore. We use the tick interpolator to smooth out our movement, so I didn't really think it was necessary to do that either. So I'm going to remove these two things, and I just set the position target, which is like where we want to go, and we just use those to determine our parent's velocity. Okay, and now this is a really important part for Netfox that I had missed in the previous section. This is another caveat, and you can see here I've got it linked here, so you'll see that in the GitHub repo. But if we just scroll to the top, this little fix where you have to add a physics factor to the velocity that will wrap your move and slide is to, I guess, overcome to be able to sync up with the Netfox's network ticks and not just whatever the physics tick of your engine is. So it's a good idea to multiply this so that we use the delta time Netfox is using and not whatever your local client is. And that keeps the player movement smooth. And if you don't have this, and if you notice something is off, definitely like he's jittery or it's not smooth, definitely wrap your move and slide calls with this. And on that note, if you are noticing some jitter in your movement, velocity seemed to be really important, a really important property to synchronize. So definitely check that out if you're having some issues with movement. So that pretty much wraps up the move player refactor. The other thing I want to touch on is before we were synchronizing under this input synchronizer, the jump input, run input, and even the just what's the other one? Input direction. We were actually synchronizing all three of those things. Well, now that we're using this rollback synchronizer, this has become obsolete. So let's actually remove that. And I wanted to do it on stream so that if you're following along, you know to keep an eye on that. So we can basically just delete that and perfect. And our player input still has this player input script attached to it. And of course, it also has client authority, just like our camera. And that's also maps to these four things. So this is kind of your inputs, which maps to your client authority things. And these are the things that we're actually synchronizing and enabling rollback, synchronization, and lag compensation. These are like the properties that it's going to have those things enabled for. And then if you want to smooth things out, use the tick interpolator to smooth out those movements. I think I've covered most of the changes. I think there was another change under camera input. Yeah, before we were synchronizing the camera mounts rotation. Let's just remove those for now. And again, this is kind of a work in progress. So like from the last stream to now, or the previous before the Netfox streams, we had a lot of stuff in here that you can see that I'm removing. So don't fall in love with anything we're doing here, because it may change just based on new information or new research or some technical debt that we were able to crack into and pay off with a lot of the stuff that I'm doing here today. So let's just take a step back. Okay, so we've got our move wrapped up. We've got our rotation wrapped up. And I don't think there was anything else in here. I'm just going to mention, just in case it wasn't clear, that I'm switching between animations in the enter. Yeah, I think I talked about this at the previous section, but the enter will get called before every single state transition by the state machine. Right. So after you exit the current state, you enter the new current state. And I'm taking that opportunity to play the current animation. And that's how you get to the different animations. And of course, each state holds its own animation. Yeah, I believe we talked about that in a previous stream. So that's just a quick recap of that. Oh yeah, force update. I don't know if I showed you where I had actually put that function, but when I talked about it earlier, it's just right here. And that was a lot to cover very quickly. And I'm sure if you were following along with this, you're going to be a little disappointed because I wasn't able to do a step-by-step on stream. Hopefully you guys are okay with what I'm doing. The other big thing that I just want to make sure that you're doing is you need to be able to call this rollback synchronizer process settings after authority is set. So I set authority on tree, ready gets hit, and I just call it here just to cap off anything. And if we go and look under our responsive player movement tutorial, the documentation will direct you to do that somewhere. Yeah, right down here. Make sure to call process settings. It establishes things behind the scenes and sets up whatever needs to be done in terms of the rollback and what gets synchronized and what's client or server authority and that sort of thing, and it sorts it out. Netfox is currently more tailored to work for a dedicated server setup. It can work in P2P, but there may be some hard codings behind the scenes. I had touched on this before in my actual standalone Netfox video. So if you want to go check that out, please go watch that. It's a really good introduction to Netfox if you don't like what I'm talking about here today, because this is specific to the 3D multiplayer template I'm working on. But let's just cap this off by just saying, make sure you run your process settings on the rollback synchronizer once the ownership has been established. The authority has been established. There we go. Yeah, we got our camera inputs. We got our different states. I can go through the states really quick. So idle, again, we just grab the input and we rotate, move. We're going to apply rotations and movement. And when you jump, once you're in a jump state, we just apply the upward velocity, and then you can kind of rotate the player and move the player at a reduced setting that I added here. And this is only probably going to run for like a frame, maybe two or three frames. And then it's going to immediately, our determined state is going to determine that, hey, you're not on the floor anymore. So you need to go to the fall state. And fall applies gravity, it rotates the player because you can kind of rotate as you're falling. And I also move at a reduced fall speed. So you can still kind of push the player forward. If you don't want to do that, you can basically just comment this out, and that wherever that player jumps to, they'll just fall straight back down, or whatever the current trajectory of that vector that they're traveling. And I've got these print statements in here. They print out some really nice debugging stuff that I thought that the guys over in the Netfox Discord kind of pointed me to. And just kind of off topic really quick, if you're, I don't want to use idle and fall, I want to use like move and see if I can find it really quick. Here we go. So I was moving for a bit. So one of the client, this is two clients probably, so it's going to be ugly. But you can see I was in idle for a while, just standing still, and it's tick, 525, 526. So each tick of that, and then we just track the frames just so, just to have that. And like fresh is, true is like an actual, input from the user, like in real time, like that prediction state, and false are basically rollbacks or like things running through your rollback tick function that aren't like an active prediction. So I believe it's part of that reconciliation phase. So it's constantly syncing and updating where you're at. And because it's idle, it doesn't really need to do anything. But once we change to move, because we got an input that was a movement input, like right here, I'm just printing out my my inputs. So 0, 1 is just like move forward. And of course it's on 529, and that's fresh, right? So that's our user actually hit that. So we move to the move state, and then we process that movement input through that move state's brain. So we process that wherever that movement input that we grab, that 0, 1, and it runs through here. We pass it to the move player function, and we apply it to whichever direction we're facing, and then we get a position, we get a vector, and then we establish that velocity and we move that direction, all based off this inputs here. And you'll notice that there's a change state idle right after it. And that might seem odd because it's like, you can see we kept moving. Well, these, if you look at, let me see it. Yeah. So here's where I moved. If you look at the actual, so you can see it change state, but the tick is out of order. It's actually running this idle tick that's like being synchronized. As you can see here, it's the fresh is set to false, so it's not an actual movement that we had just input. It's like the server reconciling those past ticks, those past states with the client to make sure that we write our past history of states correctly so that we can build correctly off of those things. So we can reconcile the player. So if they're wrong, we can correct those movements. So it's just running through them again. As you can see, 527 is back here, 528, that's back here. So it's essentially just rerunning, getting those things from the server. And before, what was happening is I was actually getting these 0 inputs, and it was during the move state, and it was telling me to actually switch back to idle. So my player in real time was going from move to idle in like the current context of trying to move the player. Whereas all these here, this one right here, look at the frame, 584. It's happening all in the same frame. So 1, 2, 3 ticks, 527, 28, and 29. So that's this guy way up here, this guy, and this one that we did already came back. We already reconciled those ticks within a single frame. And that's why you can switch from move to idle and back to move. And this one right here is actually me moving again, right? All this stuff happened within one frame, right? So it's reconciling that lag compensation back to what it should be from the server. Like, you did your move, that's your prediction. And then the server's like, yep, okay. And it passes that data back to us. And then we reconcile the history of where we were moving, where we were predicted to move. It establishes that the actual movement states, but it happens in one frame. So you correct your history with that run within that one frame, so that the next real move, which actually happened at the last part of that frame, and then the next movement, which is like down here, because I believe this is also a reconciliation idle tick 528, which is back here. By the time you get these next two moves, this guy here, this fresh one here, and this fresh one here, your history of movement will be updated, and now your movement will be based off those histories. So it's pretty complex. If you want, dive into the Netfox code, or there's some great documentation we've got in our Discord if you want to read up about it. But the whole point of what I was talking about was these print statements kind of like allow you to see those, how those things are handled. So you're not actually switching back to idle, right? That's your rollback tick. That's not a true switch to idle. Whereas before, I had all the logic to switch to states in each individual state itself was causing a false positive, and it was actually moving the player to the move state and applying those movements. So I had to refactor. I thought it was a pretty big refactor. I don't see a downside now, but I can definitely see there being room for a future improvement on this model, where I'm determining the state at the player level. And, if I end up finding out this doesn't work great, well, then we'll refactor it again. We'll revisit it, and hopefully we can, update it for the better. And, if you think of anything, let me know. Yeah, I think we've got everything covered here, guys. So I don't really have any other changes. Let me pull open, or any other things to discuss. Let me pull open my repository really quick. Okay, so this is my source tree, my repository viewer. So everything that we did in the first section of this video was all in this first commit here. And that's like the first part of this video. And then the second part was when I realized there was a big refactor that needed to be done. And that's all this code. So what I'm going to do is I'm going to commit all this stuff. This is just adding Netfox. You can see add-ons. I'm going to commit that. And shame on me for not committing Netfox as its own commit. You can see I have some other script changes in here. Or maybe not. Yeah, there's actually real changes in here. Try not to do that when you're working. I would recommend against committing new or adding libraries or plugins or whatever to your project with code changes. It's just a really messy. It can become messy. Like with a smaller template that we're working on here, it's fine. But in practice, it's really smart to add your libraries on its own commit, so that you can just uncommit that or roll back or create another branch before it if you need to work around that. So this is kind of bad practice, but I didn't make too much changes with it. Like there's just a couple little things I did here. So I'm probably just going to commit this as its own, like adding Netfox to the project. Like I said, there's just a couple, like I started adding the rollback tick stuff. But then the big refactor is all these changes you can see here. And I'll add that as a second commit. So just keep that in mind. If you want to see what I did, well, I went from here, whatever's in this staging section, and that's going to be its own commit. And then I went to here, and I'll probably keep that under this Netfox branch here. But then I'm going to commit back to our main master branch so that when you go to use the repository, you don't have to worry about like, well, which branch is he on? I'm just going to leave all the branches alone and try not to delete them. Sometimes I just do it by accident. But all right, so I'm going to do that, and I'm going to do that off stream. I don't need to do that now. But let's do a final build with our changes. If anybody's on, you have any questions about anything, let me know. I'm probably going to try to stream again soon to cover some questions that I've gotten in Discord and on YouTube. And maybe I'll put out another video on that. And I think what I want to do is start looking into W4. I've got the green light from the folks over at W4, and I'm going to start learning about that. And maybe we can deploy our multiplayer template to that and play around with what that's going to look like and how you can deploy to a cloud service that's Godot specific and tailored for that. And of course, that'll have some database stuff in there that we can look at as well, but that'll probably come at a later time, maybe in a few weeks. And okay, so we got one client. I didn't break anything. It looks good. I think I have 3 clients here. Yeah. Let me just open up the third one. Oh, the little wireframe around the guy is just the debug. I was just debugging the collision, so I added that. But yeah, you can see like the states are working fairly well. Like if I jump up on this little box here, and if you hate this movement, that's fine. You can just play around with it and implement your own. But let me go back and move this dude out of the way. Yeah. So watch him in both screens. The guy on the box right here, this guy. It'll actually, if I just walk off, it goes to the false state when he's not on anything, when it's not detecting. And I think that's just, it's a really subtle thing, but I think it makes a really big impact. So, if you wanted to have a different type of fall animation, or maybe after he falls for more than 2 seconds, I don't know what kind of cliff would be. Maybe if you're like falling a really far away, you have this like terminal velocity fall that you could add another state in there. And let's just connect to a third client. And again, these are connected to a dedicated server that has Netfox lag compensation and server reconciliation enabled on a backend that's hosted across the country from me. And so I'm able to move around really smooth, and you can see it's being synchronized just fine. And again, there is a little bug with the rotation being synchronized. I've seen that. If you've seen that and you know what the fix is, let me know. But I'm guessing it's not too big of a deal. And once I push out a change for that, just follow the repository or follow me on social. Maybe I'll put out some stuff, or even on YouTube, maybe I'll put out an update. But all right, so that pretty much wraps up this stream. I don't really have anything else to cover. I think this is a pretty good template. You could really start into this template and just start adding stuff to the ground and just build out a small little world. If you want like a little open world or something like that, you want everybody to connect to, or you can use this as a starting point to create levels. Like if you wanted to have different levels in your game, like right now, everything is spawned into this map spawn point, right? You could actually create a synchronizer and a spawner wrapped around this map spawn point. Like I have a player spawner where you can have like a level spawner and swap out levels for competitive games and that kind of thing, like match-based games. It just depends on what you want to do. So I think we've got everything wrapped up for lag compensation. We've got our 3D multiplayer running and working fairly well, other than that small little rotation bug. So I'm probably going to pause on working on this unless by popular demand you guys want me to keep adding more stuff to it. We can definitely add stuff to it. And when I say pause, I kind of mean like a temporary pause, because the videos I was working on before were the Brackeys based videos, and I kind of wanted to have my own thing. So I want to add additional functionality to this, like database support, like saving data for your game, and authentication. And I think this would be a good medium to do it, because it's really easy to follow, in my opinion. And it's not somebody else's game at that point. This is kind of something that, we've been working on together, or I've been streaming together with you guys. So, and it's not based on like Brackeys or somebody else's stuff. So I think I'm just going to stick with this and build upon this for a while. But when I say pause, I think I just mean that I'm going to focus on some other stuff for a little bit, like the W4 deployments and maybe some other service providers. And then we'll circle around to, saving data, maybe through some RPCs that we can save to a database from our backend server and that sort of thing. So look forward to that. Have that upcoming. And please, if you want to see more content, let me know what you guys want to see. Hit me up on any of the socials or YouTube, and make sure you're subscribed and you like the video if you enjoyed it. I've got a store out there if you want to support me. Also, I have a Patreon out there, and I'd appreciate any and all support. So thanks for watching today, and I hope you learned something about Netfox, at least in the 3D world. And again, everything I'm doing here can be used in a 2D world. So any of the 2D or 3D videos I do with multiplayer stuff will translate respectively between each other pretty well. I would say the only thing that wouldn't work perfectly is the type of camera, right? Like you're not going to be synchronizing in 3D a 2D camera necessarily. So you'll have to figure out, which things that you want to synchronize or which things that camera needs to be refactored to support 2D versus 3D. And then like movements and that sort of thing, instead of just synchronizing a transform, I guess it still could be transform for 2D players, but your inputs may be different and that sort of thing. So it's really just a minor refactoring between 2 and 3D. But yes, anything that I'm doing, I get that question a lot on YouTube and in Discord, like, can this work in 3D or 2D? Yes, you can definitely use all this. There's really no difference. It's networking. You're just changing the type of data you're sending. But anyways, that's enough for today. Thanks for stopping by, everyone. And I will see you in the next video. Thanks for watching.